In this video, we are going to look at practice problems examples 154 to 157. So these are the problems related to partial fraction technique. Let's start by looking at integrate 1 over x plus 5 square over x minus 1 dx. So you can see that this is clearly a question on partial fraction technique, because on the numerator you have just 1, on the denominator you have x plus 5 square times x minus 1. So first of all, you need to set up the decomposition. So I'm going to set up 1 over x plus 5 square times x minus 1 to be a over x plus 5, and then plus b over x plus 5 square, and then plus c over x minus 1. All right, and then after that, I have to clear out the denominator. So I'm going to have x plus 5 square here times x minus 1. So the first term going to be a times x plus 5 times x minus 1. All right, and then plus b times x minus 1, right? And then plus c times x plus 5 squared. All right, you can observe that the term that I wrote in green, those are equal to each other because, well, they are both numerator. All right, now starting from the one that I highlight in green, we need to find an exact value of A, B, and C. All right, so we are going to pick some number. Technically, you have two ways to solve for A, B, and C, comparing coefficients or picking an appropriate set of numbers. So we are going to just pick when x equal to 1. The reason why I pick 1 because I see x plus minus 1 here. So I hope that if I pick x equal to 1, it's going to cancel out a lot. So we have 1 equal to, well, 0, right? Because the first term we have x minus 1, so it's going to go to 0, and then plus 0, and then plus c times 6 squared. Well, that means 36c equal to 1, and that will give me c equal to 1 over 36. Good. All right, we have when x equal to negative 5 next. The reason why I pick negative 5, of course, because I have x plus 5 on the right hand side. So this term going to be 0, and then plus b times negative 6, and then plus 0. Well, which means I have b equal to negative 1 over 6. Well, that's the piece of cake. When x equal to negative 4, we have 1 equal to a times 1 here, and then times negative 5, right? And then plus b times negative 5, and then plus c times 1 square. The reason why I pick negative 4 here, people, this is because I have x plus 5 on the right hand side. I hope that if I plug in x equal to negative 4, so I get just small number. Well, because x plus 5 would be 1, right? And then I simplify a little bit on the right hand side, so I'm going to have negative 5a, negative 5b, and then plus c. All right, because I already know the value of b and c, so I can solve for a. So I'm going to plug in that number, so negative 5a minus 5 times 1, negative 1 over 6, and then plus 1 over 36. So on the right hand side now, I have negative 5a plus 5 over 6 plus 1 over 36. So 5 over 6 here, this is going to be 30 over 36, right? And then that means I have negative 5a plus 31 over 36. Well, on the left hand side, I have 1. All right, that means 5a, this is equal to 31 over 36 minus 1, which is negative 5 over 36. Well, at the end, well, if you cancel out number 5, so you're going to get A equal to negative 1 over 36. Well, it is possible that you gonna solve this ABC different from me, and you can find a way that is shorter than me. That's fine. This is depend on your technique. All right, so we have A, B, and C. So we're gonna just plug in A, B, and C and then integrate. So we are going to copy that. Then I'm gonna paste it on the next page here. So we want to integrate this thing dx. So that means we need to integrate this thing dx. Well, because I already compute A, which is going to be negative 1 over 36. So I have negative 1 over 36. Integrate 1 over x plus 5 dx. And then I already compute B, that is negative 1 over 6. Integrate 1 over x plus 5 square dx. And then the last one I already compute C, which is 1 over 36. Integrate 1 over x minus 1 dx. So these three constants A, B, and C, they are from the previous slide. Now we need to integrate. So integrate 1 over x plus 5. This is log absolute x plus 5. And then minus 1/6. So integrate 1 over x plus 5 square. So this is going to be x plus 5 to the negative 1 over negative 1. And then the last one, you have plus 1 over 36 log absolute x minus 1. Well, do not forget to plus c. Well, you simplify a little bit, so you're going to get negative 1 over 36 log absolute x plus 5, and then plus 1 over 6 times x plus 5, and then plus 1 over 36 times log absolute x minus 1 plus c. All right, this is going to be your final answer for this question. All right, we have 3 more. Let's move to example 155. Well, clearly this is the partial fraction technique. First of all, when you have partial fraction like that, so you need to make sure that this is a proper fraction, right? Proper rational fraction. So the highest degree on the top is 1, and the highest degree on the denominator is 3. So fine. So we do not need to do the long division. So we are going to set up the decomposition. So negative 2x plus 4 over x squared plus 1 times x minus 1. So I'm going to set it up to be, well, if you need a squared, if you need x squared plus 1 on the denominator, you need ax plus b on the top, right? Because on the denominator, you have x squared plus 1, and this is irreducible. So you have ax plus b on the top, and then x plus 1 here, so you have just c. Well, now your turn is you need to compute a, b, and c. So we're going to clear out the denominator first. All right, so we have ax plus b times x minus 1, and then plus c times x squared plus 1. All right, so first of all, we are going to solve for c first, because you can see now that negative 2x plus 4 and that term that I boxed, they are equal to each other. So we're going to plug in when x equal to 1. So what happened? So when x equal to 1, so you get negative 2 times 1 plus 4 equal to 0 plus c times 1 squared plus 1. Well, that means 2 equal to 2c, and that means c equal to 1. All right, pretty simple. And then, well, now I need 2 more equations to solve for b and a. So I'm going to pick an easy number so I can compute it easily. So I'm going to pick x equal to 2. Well, the reason why I pick x equal to 2, because if I plug in on the left, I have 0, right? And if I plug in on the right hand side, I am going to have ax plus b, which mean a just a plus b, 2a plus b now, and then multiply x minus 1, which is 1, right? Because x equal to 2, and then plus c. Now c is just 1, so I can drop c, and then c is just 1, and then x squared plus 1. This is 5, right? Well, here on the right hand side, I have 2a plus b plus 5. So we're going to save this one for equation number 1. All right, I start it. So next, I'm going to do look at when x equal to -1. Well, I have -2 times -1 plus 4. So on the left hand side, I have number 6. So on the right hand side, I have -a plus b, right? Because I plug in x equal to -1 and then times -2, and then plus c is 1, and then -1 square plus 1. This is just 2. So that's mean now I can simplify a little bit. So I have also 2a, right, minus 2b, and then plus 2 equal to 6. This is the second equation. Star minus equation double star. So what I'm going to have -6, right, equal to 3b plus 3, right, because I just subtract equation. All right, next, that means -9 equal to 3b, and I can solve for b now. So my b, this is going to be tick tock, -3. All right, so once I solve for b, so I can solve for a. So to solve for a, because I have 2a plus b plus 5 equal to 0, so that's mean 2a minus 3 plus 5 equal to 0. That's mean 2a plus 2 equal to 0. So that's mean a equal to -1. All right, we are done. So a equal to -1, b equal to -3, and c equal to 1. A equal to -1, b equal to one more time -3, and c equal to 1. Well, you may, as I told you, you may have another way that you can compute faster than me. Well, go ahead and do it. But for this question, we are going to copy that, and then we're gonna just plug in our number a, b, c. So number c, this is just 1, right? Number a and b, a is -1 and b is -3. All right, that's mean when you integrate, so you integrate that dx, right? This is going to be integrate on the right hand side here, dx, right? Well, on the first term, you're gonna have negative x over x squared plus 1. So I split it into the first term here, and then I split it into -3 over x squared plus 1 dx here, and then I also split it into 1 over x minus 1 dx here. The reason why I do this because you can see that I have x squared plus 1 on the denominator, and to integrate something on the top over x squared minus 1, well, if something on the top is just a constant, you have the arctan formula. Well, you integrate and then you're going to get arctan, right? But if you have something that is just the linear factor of x, so you can see that you're going to use substitution, so you can cancel out, and this is integrable. So here you're going to have integrate. Well, I'm going to pull out negative side first. Well, I have integrate x over x squared plus 1, and then I switch this into dx squared plus 1. This is over 2x. So 1x going to cancel, right? And then plus -3, and then integrate 1 over x squared plus 1. This term is good because it's going to go to arctan. And the last term, I don't touch anything. So now I am ready to integrate. I'm going to integrate the whole equation here. So I'm going to get negative 1/2 log absolute x squared plus 1. Technically, because x squared plus 1 is always positive, so you can do the soft parenthesis here, and then minus 3 times arc tan x, right? Because this is just the formula for integrate 1 over x squared plus 1 to get back arc tan x, and then plus log absolute x minus 1 plus c. All right, this is going to be the answer for question 155. So let's move to the next one. All right, 156. All right, this is a little bit complicated because you have x squared plus 1 and x squared plus 2 on the denominator. Well, keep in mind that on the denominator you have degree 4 and on the top you have degree 3. So this is still good. This is a proper one. So you can start doing partial fraction now. We are going to set up x cubed plus x squared plus 2x plus 1 over x squared plus 1 times x squared plus 2. Well, this is going to be ax plus b over x squared plus 1 plus cx plus d over x squared plus 2. So now you have 4 unknowns. So it is going to be a little bit tough, but well, we'll see. We're going to clear out the denominator first. So we're going to have ax plus b times x squared plus 2 and then plus cx plus d times x squared plus 1. Because we have 4 unknowns and then the term on the numerator is not that complicated, so I can expand it. So for this question I'm going to try to expand and compare coefficient. Just switch the way so you can see something different. So for this question I am going to expand that on the top. So I have a x cubed and then plus bx squared and then plus 2ax and then plus 2b. All right, before moving to the next step, make sure that you expand it correctly. So for this question I'm good. All right, that's the first term. So the second term I have cx cubed plus cx and then plus dx squared plus d. So you need to be careful a lot for this one. And that is equal to x cubed plus x squared plus 2x plus 1. So on the right hand side, you just need to group the term to something, just group the cubic term together, square term together. So we're going to have a plus c x cubed. And then we're going to have, for x squared, we're going to have b plus d x squared. And then for x, you're going to have 2a plus cx. And the last one, you're going to have 2b plus d. All right, this seems pretty good so far. Now we are going to compare the coefficient. So on the left hand side, I have 1x cubed plus 1 times x squared plus 2 times x plus 1. All right, since we have 4 unknown here, so we have 4 equations: a plus c equal to 1, b plus d equal to 1, 2a plus c equal to 2, and 2b plus d equal to 1. All right, this is pretty simple because you can solve for a, b, and c easily. So you can see that on the first equation and the third equation here, this will give you a equal to, well, if I subtract these two equations, so I'm going to get a equal to 1 and b equal to 1. Not b, sorry, c equal to 1. 2b plus d, I'm going to subtract with b plus d. So what I have here, I have b equal to 0, right? And d must be 1. All right, so I have this. Your decomposition is going to be x over x squared plus 1, right? because you plug in a equal to 1 and b equal to 0 plus x plus 1 over x squared plus 2. All right, that is the second term. So we're going to use this thing to be our integrand on the next page. All right, so we need to integrate that. So this is going to be, on the first term, this is easy, so it's going to be x over x squared plus 1 dx. This is pretty simple. So on the second term, well, you have x plus 1 on the top, and you have x squared plus 2 on the denominator. My suggestion is, well, you should split it to x over x squared plus 2, because this term you can use substitution. The next term you have 1 over x squared plus 2. This is going to be the term that you can do the arctan thing. All right, we are going to use substitution first. So this is dx squared plus 1. So I'm going to have 2x here, then plus integrate x over x squared plus 2 dx squared plus 2. So I'm going to have 2x here, and then plus, well, the last term, well, you can say this is integrate 1 over x squared plus square root 2 square. And then you can get just, the formula for arctan thing. So if you can remember, so the one that I just told you in class, that when you see the, let me go back here. So when you see the integrate 1 over x squared plus a squared here, so you're going to get 1 over a arctan x over a here. This is what we just proved in class, so we're going to use it again on this question. So come back to our question now. So we are going to cancel out here x and x. So you have 1/2 times log absolute x squared plus 1, but because this is positive, I can just do the parenthesis. Here we are going to cancel out x, so you have 1/2 times log x squared plus 2, and then the last one you're going to have 1 over square root 2, and then arctan x over square root 2 plus c. Example 157, we have improper rational functions. You can see that on the integrand here, we have rational function for which degree on the top is equal to 3 and degree on the bottom is equal to 3. So first of all, I am going to simplify it to integrate from 3 to 4 of x cubed minus 2x squared over x cubed minus 2x squared. And then I split number 4 to the next term. Well, the reason why I do this because, well, on the first term I can cancel out this thing, and then I am going to have integrate 3 over 4, 1 minus 4 over x cubed minus 2x squared, which I can pull out x squared and then factor out. Well, it's going to be 4 over x squared times x minus 2. Good one. So now you can see that here on the second term here, 4 over x squared times x minus 2, I can use partial fraction technique on this term. Well, for those of you who don't know how to split this thing into 2 pieces, you should practice. So sometimes you just need a long division to reduce the improper rational fraction to the proper fraction. So I would love to start this question because maybe on the exam you're gonna see the question that give you an improper rational function, and then you just need to use the long division to reduce this to a proper fraction. All right. Next, we are going to set up the partial decomposition. 4 over x squared times x minus 2. This is going to be a over x plus b over x squared, and also plus c over x minus 2. All right, if you clear out the denominator, so you're going to have a times x minus 2 plus b times x minus 2, and then plus c times x squared. All right, this is equal to 4. So if you plug in x equal to, let's say 2 first, so you're going to have 4 equal to, well, the first term is 0, the second term is 0, and the last term is equal to 2 square, which is 4c, right? That means your c is equal to 1. All right, you obtain one unknown already. So the next one I can plug in when x equal to 0 because I want to see the first term to be 0 and the last term to be 0. So the second term gonna be negative 2b. All right, that will give you b equal to negative 2. All right, next I am going to pick x equal to 3. Then I have 4 equal to a times 3 times 1, and then plus b times 1, right? And then plus c times 9. All right, that looks good to me. All right, now I have 4 equal to 3a plus, well, b is negative 2, and then c is 1. All right, that means 3a plus 7. So that means negative 3 equal to 3a. Okay, and that means a equal to negative 1. All right, you have to be careful and go slow on this step because you cannot mess up on the decomposition. All right, so I'm going to change the color to black, and then now I have negative 1 over x here, and then plus, actually minus 2 over x squared, and then okay, the last one is plus 1 over x minus 2. So I have this thing, I'm going to replace it into the one that I highlight in green. Sounds good. So let's go to the next page. We are going to copy this thing, and then we're gonna do that on the next page. All right, from what I did last slide, so I am going to have integrate 3 to 4 1 minus 1 minus x squared, negative 1 minus x negative 2 over x squared, and then plus 1 over x minus 2. All right, dx. Sounds good. Let me clean this thing. All right, good. Now I can simplify a little bit. So I get from 3 to 4, 1 plus 1 over x plus 2 over x squared, and then minus 1 over x minus 2 dx. Looks pretty clean and easy to integrate. So let's do it. It's going to be x plus log absolute x, and then plus 2 times x to the negative 1 over negative 1, and then minus log absolute x minus 2. Well, then you have to evaluate from x equal to 3 to x equal to 4. All right, so let me change a little bit. So x to the negative 1 over negative 1, this is just 1 over x. So I'm gonna delete that term to be negative 2 over x. All right, now we just need to compute that thing. So you're gonna get 4 plus log 4 minus 1/2 minus log 2. All right, and then minus 3 plus log 3 minus 2/3 minus log 1. So log 1 is 0, so it's go away. All right, now you can group it up. So you can group 4 minus 1/2, which is 3.5, and then minus 3, which is 1/2, and then add 2/3. Well, here, once you compute these 4 numbers, so it is going to be 7 over 6, right? And then plus, so you have log 4 minus log 2 minus log 3. Well, actually, if you simplify a little bit more, log 4 minus log 3 minus log 2 minus log 3, this is going to be log 2 over 3. All right, that is our answer. All right, that is going to be the end of this clip too. All right, next clip we are going to look at trigonometric integrals and trigonometric substitution.